Hi, welcome to Computing Foundations. This is a YouTube channel for beginners who want to learn about computers, software, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. Today we are pressing forward and continuing our journey in the C programming language, and our topic is structures and other user-defined types. If you've made it up to this point in the videos, I just want to say I'm really proud of you. We have made quite a bit of progress since our first video on variables. We've learned about a lot of things, and in the next few videos we're going to be pressing into some more advanced topics. Sometimes these topics are not even discussed in an introductory programming course. So you could say, starting with this video, you're beginning to move beyond just the basics of the C programming language, and you'll be learning about some of its features that are a little more advanced that we're going to be using as we move into other courses like data structures and algorithms. But let's get started with structures. So a structure is a user-defined type, and by that I mean you've seen the intrinsic types of the C programming language, the integer, the floating point, the character. We've seen how to combine those into arrays where we can have many integers, many characters represented by a single variable. Well, with a structure, we can begin to define a group of variables that are not of the same type. So we can put together several variables that are not of the same type and refer to them with one common name. So why would we want to do that? Well, let's think of an example. We've done a challenge program where we created a simple phone book. And I want to think with you for a minute, what are some of the types of data that we normally would see in a phone book? Well, typically, as we saw in our first example program, usually the entry will have a name for the person. That's pretty obvious. We've already programmed that. There'll be a phone number, but sometimes, as you know, there might be 3 different phone numbers, like one for work, one for mobile, maybe one for home. What else do we typically see in an address book? We might see the person's physical address, where they live. We might have information about their birthday. What else can we see in a phone book? We might have information about more intimate things like the date of their marriage, their anniversary. Okay. We might have what company they work in. Okay, you get the idea. There's a number of different types of data that we want to store in a phone book with each entry. And up until now, we've seen this technique that is called parallel arrays. So what this means is, in order to represent each element of the phone book, we'd have to create a unique array that will hold the entries of the phone book. So the entire phone book is represented by a group of arrays where each multi-dimensional array, the first dimension is the entry in the phone book. And then, we have several different arrays where if we want to access all the information for a given entry, we have to access several different arrays, one array for each element in our phone book. And this works, but it's generally considered a little bit of a messy practice because you've created variables that are very closely related to each other, but you've stored them in different structures, different arrays. And the only way that they're related to each other is that a related entry has the same initial index into each of the arrays. So structures are going to give us a different way to approach organizing data like this. So let's take a look at a basic structure. This is what the definition of a structure looks like in the C programming language. We use the special keyword struct, S-T-R-U-C-T. Then we give our structure a name. Here I've said PB for phone book entry, open curly bracket, closed curly bracket, a special semicolon that you can't forget. And we then list individual variables. They can be arrays or just single variables. As an example, I could have added into this definition an integer for the age of the person. So they don't, all the entries in the structure don't need to be arrays. It just so happens that in this structure, I've made everything an array of characters because I'm storing strings. But we could have had something else, like maybe the age of the person. All right, so this is how I define a structure. But the way this works is, this is just the definition of the structure. If I want to actually create a variable, if I want to create an instance of this structure, I define a variable just like I've done with other types of variables, where I'm going to put the type first, then the name of the variable. But in order to create a variable of a structure type, I use the keyword struct, and then the name of the structure. This is the definition of the structure. And then here's my variable. So now my entry represents a single instance of this structure definition. So behind this variable is a block of memory that can store all of these different elements. How do we access or reference these elements? So here's what the syntax looks like. We take the name of our structure variable, follow it by a dot or a period, and then the field name of the structure that we want to access. So in this case, my statement isn't doing anything, but you can see here, I'm just referencing the variable of each of these different elements of the structure. So I also could define an array of my structure, So here I am creating, sorry, I'm going to go into do not disturb mode because I'm getting beeped. Here I'm creating an array of 100 elements where each element is my structure. So I might call this a phone book with a bunch of different entries in it. So I could say my book sub 0 dot phone, my book sub 0 dot address. This is how I would access the different elements of my structure. All right. So this is how we define a structure and how we create variables of type of the new structure and how we can access the different variables inside the structure. So let's talk, as we've done with other different types that we've discussed, how do structures work inside functions? How do you pass a structure into a function? Well, if you pass a structure into a function, as I've defined it here, it will be passed by value. So here I can print %s, e for this is my structure variable, e dot first name, e dot last name. So I can happily print out the values inside the structure, but I can't change the values inside the structure because this function definition is a definition that will pass the structure by value, meaning it will pass a copy of the structure into the function. Now I can access everything, but I'm not able to change anything. So let's take a look at how would I pass by reference. How could I pass a structure into a variable by reference so that I could actually change it? So here's your example. I set up my function. I define a structure parameter, but instead of just defining it as struct PB entry, I define it as struct PB entry star, meaning now I'm defining a pointer to a structure, So I won't be passing in a structure by value, I'll be passing in a pointer to a structure, a pass by reference. And here because I've called this function setName, I'm going to pass in a character array that represents the first name of the person. So here I can set into this entry, I'm going to do a string copy, and this is the special operator that I wanted to introduce you to. It is a right pointing arrow, and it literally, to type it, we type a minus sign and a greater than sign. So I type a minus sign and a greater than sign, and then the name of the element of the structure. I have to use this operator when I'm operating with a pointer to a structure. This is how we dereference the values inside of the structure when we have a pointer to them. So EP arrow first name, and then I copy in the parameter that was passed into the function. So this is how I work with the structure in a function, depending on whether the function needs to just read the structure or if the function needs to change the structure. There's one more user-defined type in the C programming language, and it's called the enumeration. So I'll quickly go over this. It's different from a structure, but another type of user-defined variable type. So we create an enumeration like this. We use the special keyword enum, then we have a name for the enumeration, and then we have in curly brackets just written words. They don't have to be inside quotation marks. They're not strings. These are more like special variable names. So what I'm defining here is I'm saying I want to define an enumeration of name suits, and the possible values of this enumeration are spades, clubs, hearts, diamonds. These are the suits of a deck of cards. So once I've defined this enumeration, I can define a variable, my card, of type enumeration suits. So this is now a variable of type suits, and I can set it equal to one of the suits. So I can say my card equals clubs. Behind the scenes, the compiler is treating these as integers. So each of these special named identifiers have a value, and you're setting that value into your variable. But inside your code, you're not writing integers, you're using these special keywords that you've defined, which are the values of the enumeration type. So here, if I were to print out my card, I would print it out as an integer, and it would have the value 1. Because in an enumeration, each potential value of the enumeration takes on a incrementally increasing integer value starting at 0. So spades is 0, clubs is 1, hearts is 2, diamonds is 3. You don't need to know what the values of these enumeration type values are. It's just that they need a value so that you can compare them and work with them and see if they're equal to each other. Let's take a look at another example. So here, I'm going to define an enumeration called faces. These are for the names of the cards that have faces. And I'm going to say Jack, Queen, King, Ace. But I'm doing something new here. I'm setting the first value equal to 11. The compiler will honor this and it will use 11 to represent Jack. And each of the following values, it will just assign an incremented value from the first value. So Queen will be 12, King will be 13, Ace will be 14. So now, if I define a variable of type faces and I set it equal to Ace, and I print its value out, the value will be 14, as we've said, 11, 12, 13, 14. If I define another variable called your face and I set it equal to Queen, look what I can do. I can say, if my face is greater than your face, if my face beats your face, if it has a higher value than your face, then print out, I win. So in this instance, my face is Ace, your face is Queen, Ace is greater than Queen based on the way I've defined my enumeration, and the compiler will evaluate these two variables as integers and we'll get the result we expect. If my face has a greater value than your face, then it will print out I win. So in this way, I can define an enumeration that represents some sort of concept that I want to use inside my program, and then I can define a variable of that type and assign values that are easy to read. The user reading the program can say, oh, I get it. There's 4 different types of face cards, and I can set the type of the face card in the program using the special names that were defined in the enumeration. So enumerations are a way to make your programs easier to read, more logical, by defining your own type. Okay, let's look at another challenge. So what I want you to do to practice making use of this concept is I want you to rewrite the phone book application that we wrote from one of the past challenges. But write it using structures. Don't have an individual array for each different field in your phone book. Each entry has a bunch of fields. Don't have an individual array for each one. Use a structure. And add one new field to your structure that is an enumeration type. As an example, maybe you're going to put the person's eye color into the phone book. And so we need an enum variable that will hold different eye colors. Blue, brown, green, black, whatever colors you want to support. So now I want our phone book, though, to have one extra command. We'll have the add command to add an entry, the display command to display everything in the phone book, and a last command that I want to call M. And what I want the M command to do is to display the bytes of memory in the structure. So the user will press M, and then you will solicit from the user an index in the phone book from 0 to however many entries are in the phone book. And this M function will look up the address of that entry and print out the memory represented by the entry. So you're going to be printing the memory of a structure, just like we did for character arrays. My goal here is that I want you to be able to see how the memory is laid out. And you'll see that each variable in your structure has a predictable amount of memory. And in that memory are the values that you've set into the structure. So this is an exercise. We're creating a new function, a new command to print out the memory of a structure so you can visualize how the structure is laid out in memory. Okay, good luck on this. As always, we'll post the solution as well as a video going over the solution. And don't forget to take a look at the sample program number 14. It's called 14-structures, where I go over example uses of structures and enumerations to help make sure you've understood the concepts in the video. Then after you've gone over that, work on your number 14 challenge, creating a phone book using structures. We'll see you in the next video.